Hello, welcome back once again. Today we have this interesting complex equation. I raised to the power of k is equal to I times k. In this video, we're going to find the values of k that will satisfy this equation. You may be asking, what is I? I is known as the imaginary unit, which is equal to the square root of a -1. Let's see how we're going to solve this problem. I know at first glance we have an obvious solution, which is k is equal to 1, right? As we can see, that anything raised to the power of 1 is equal to that thing times 1. There's another solution, but not easily to get, and that is k is equal to -1. Yes, this is another solution, but that's not easy to get, because I raised to the power of -1 will give you -I, and at the right hand side we have -I. But let's solve this problem. First, let us divide both sides by I times I to the power of k. So here we have I raised to the power of k, then divided by I times I raised to the power of k. So this is equal to I times k divided by I times I to the power of k. From here we have this nice cancellation, and from here we have this nice cancellation. So from the right hand side we have k times, so 1 over I to the power of k. If you use this law of n, this is 1 over a raised to the power of n is equal to a raised to the power of -n. So this becomes I raised to the power of a -k. So this is equal to, we have 1 over I at the left hand side. So 1 over I, if you multiply the numerator and the denominator by I, you get I over I squared, which is -I. Interesting. So from here, we're going to multiply both sides by -1. But before doing that, let's multiply both sides by -1. So here we get -k times I raised to the power of -k. This is equal to a positive I. Now let's use this identity. A raised to the power of b is equal to e raised to the power of b times the ln of a. So therefore this becomes -k times e raised to the power of -k times the ln of I. So this is equal to I. For us to make this power here equal with this coefficient, we multiply both sides of this equation by natural log of I, and that gives us -k times the natural log of I times e raised to the power of -k times the natural log of I. This is equal to I times the natural log of I. Okay, let's take the Lambert W function on both sides of this equation, and we are obviously very familiar with this function. So the W of k times e raised to the power of k is giving us k. The left hand side simplifies to -k ln of I is equal to the W of I times the ln of I. Okay, so I think the right hand side will simplify nicely as well, right? Because this is same as the W of, this is e raised to the power of ln of I, right? And then times ln of I, which also simplifies to ln of I. So we have -k times the ln of I is equal to ln of I. Okay, I think there's another thing very cool to do from here, because if you divide both sides by ln of I, this one will provide us with the solution k is equal to -1. So, right, because if you divide both sides by ln of I, but I think we have another cool solution from here. And what is that going to give us? I think this is the only solution we have from here. So from here we can put the solution in general. Okay, so from -k ln of I equals the W of I ln of I, divide both sides by -ln of I, so we get k is equal to -w with a subscript of n, where n is an integer of I ln of I, then divided by ln of I. So at some branches of this Lambert W function, where we have n is equal to 1 and n is equal to 0 and n is equal to -1, that's where we found our solution plus or -1. But other branches will give us the complex solutions, which are infinitely many complex solutions that satisfy the given equation. Thank you for watching. If you enjoyed the video, kindly subscribe, also like, comment, and share.